For this experiment, you'll be performing what is called TLC, or thin layer chromatography. It's a simple, fast, and effective technique used to separate and identify compounds within a mixture. It works by applying or spotting a small amount of sample to a plate coated with a thin layer of adsorbent material like silica gel. The plate is then placed in what's called a developing chamber with a solvent, and the solvent will naturally migrate up the TLC plate by capillary action. And in doing so, it carries the compounds in the sample with it. However, depending on their polarity and their affinity for the absorbent, the spotted samples will generally migrate up the plate by different amounts. The data you'll collect today from this simulation includes the distance the solvent front traveled up the plate and the relative distances that each of the compounds migrated up from the baseline. These differences are used to calculate what is called the RF value, which is the ratio of the distance traveled by the compound to the distance traveled by the solvent. These RF values are a characteristic measurement for each compound under specific conditions, so they can be used to compare unknown samples to known references, aiding in compound identification. This makes TLC an essential tool for analyzing purity, identifying unknown substances, or monitoring the progress of reactions. So let's get started. So to start, what we're going to do is get our developing chamber and fill it with the solvent that we're going to use today. We can do that simply by clicking on it and clicking it to the place where we have to put it. We're going to zoom in to the dispenser and then use our up arrow key to withdraw the solvent and our down arrow key to dispense it into the developing chamber. For those of you on touchscreen devices, there are on-screen buttons to do these same operations. Next thing we're going to do is prepare our TLC plate. We do that by long clicking on the plate and selecting the appropriate option, and then we'll draw the baseline as well as draw the individual tick marks because we're going to spot three different samples for this experiment. So we'll do that for each TLC plate. Again, long clicking, clicking prepare the plate, and then long clicking again to do each of these individual operations. And each of these lines is telling us where we're going to spot our respective samples. So the first thing we're going to do is take our unknown. Our unknown is in solid form. We're going to click on it, and that'll allow us to dispense it into the test tube that we have on our benchtop. Now, you'll see these blue lines, blue circles around objects that are selectable. And when we select them, they become multiple blue lines, as you can see there. So dichloromethane is the solvent that we're going to use to dissolve our unknown. And what we do is we pour a little bit of that into that first beaker, and then we use a disposable pipette. And this is all by clicking or tapping around the interface to use these. And by placing our disposable pipette above our unknown sample, it's going to drop in an appropriate amount of that solvent to dissolve it. If you at any point in time want to zoom in to a piece of the equipment, you can simply double click or double tap, and the enter key will always zoom you back out. So next thing is to grab a capillary tube, and the capillary tube is a very small tube that will draw up a small amount of sample that's useful for spotting onto the TLC plate. Now, to actually do the spotting, what we're going to do is, again, long click onto one of the TLC plates, and that will give us our options. We're going to spot into the right lane, so it's the right-hand side tick mark, and we're also going to spot into the middle lane, because in the middle lane of these TLC plates, we're going to have both of our samples spotted, both the unknown as well as the reference that we're using. We're using a couple of different references today. And once you've done that, you'll notice there's no more options on that particular plate. So we'll go to the second plate, again, long clicking on it. We can spot our sample onto the right lane, and then we can also spot our sample onto the middle lane, which is what our co-spot lane is called. After that, we'll discard our capillary tube again by long clicking onto the tube. That'll give us the option to discard it. And now we can proceed with our reference samples. Now, it's helpful to zoom in and out, and you can do that by scrolling. We're going to pick the first reference sample here, which is benzophenone. We can get a small sample just by clicking on it to pour into our transfer beaker here. And now what we're going to do is spot this reference sample onto our TLC plate. So we'll grab another capillary tube. We do that by clicking. Then what we'll do is click on the capillary tube and insert it into the benzophenone sample. And now, as we did before, we'll long click on the TLC plate, which will spot the sample in the reference lane for us. And then we'll long click again to add another reference sample spot to the co-spot lane, which is in the center of all three lanes that we've crafted. So now we want to do that same process again for the second TLC plate. We're going to use a different reference sample, which this time is biphenyl. We'll click on our biphenyl sample to pour a little bit, approximately 50 mils, into our beaker. We'll then get another capillary tube and insert it into that reference sample as well. Now, as we did before with the first TLC plate, we're going to long click on the second TLC plate and spot our reference sample in both appropriate places, both the reference lane on the left as well as the co-spot lane on the middle. Now, after discarding the final capillary tube, we're ready to place our TLC plates into the solvent. So we'll do that by clicking. They'll go into the developing chamber. And when you double click on that developing chamber, you'll see that solvent front move up the TLC plate. You want it to get as high as possible, but not to the top, because you need to know the relative difference of how far the solvent moved up to how far the samples moved up. So when it gets close, you'll hit the enter key and the simulation will pull out those TLC plates for you and put them on your bench top. Now we're ready to make some measurements. The first thing we'll need to do is mark where our solvent front stopped. And so we're going to go to the overhead view by long clicking on the TLC plate, and then we can long click again to mark that solvent front. That's going to mark it with a pencil line, and it's going to remind us how far the solvent traveled in this particular experiment. In order to see the samples, what we're going to need to do is expose them using UV. In this view, we can see where each of our samples traveled to as they migrated up the plate with the solvent. We can mark those for later analysis by clicking on each of the spots. You can see where the right lane spot ended, where the left lane spot ended, as well as where the two spots traveled to in the co-spot lane in the middle. Now, in some cases, your reference lane as well as your sample lane will have compounds that traveled almost identical distances. And in this case, your co-spot lane in the middle, which has both, will be difficult to distinguish. So clicking on it twice will allow you to mark each of those two, even though they're in very similar positions. At this point, you've finished the simulation, and the only thing left to do is collect some data, specifically about the RF values I mentioned before. By double-clicking on any of the TLC plates, you can go to the overhead view, which will allow you to do those measurements. Recalling what each of the spots contained, you can make a measurement from the baseline to those spots as well as the solvent front, and that will allow you to calculate your RF values for each of the spots. Because these are ratios of distance, it really doesn't matter what tool you use. You could literally measure them off your computer screen if you like. And that concludes the simulation. Be sure to let us know if you need any help.